First we will see in what is this increasing and decreasing functions. So any function you take y equal to f of x, any function, or this is only curve. Okay, any function you take, if you draw the curve, okay, this curve must be either increasing or decreasing or constant, or neither increasing nor decreasing. Not decreasing. Okay, so so how do we check whether it is increasing or decreasing? That means what? As x goes on like this, x value is going like this. Okay, so let's say this is 0, like this, y-axis, x-axis. As this is x values are going like this. X values are going like this. So let's say 1, 2, 3, 4. That means what? As x is increasing. This all we take as x is increasing. So now, so let's say y value at 0, it is here. Y value is here. At 1, it has come here. At 2, it has come here. At 3, it has come here. At 4, it has come like this. It's going like this. Like this, it's going. It's going like this. That means what? Whether it is increasing or decreasing. Increasing or decreasing? Question.
Increasing.
Huh?
It's increasing.
Increasing.
Yeah.
You are able to hear my voice? Vishta?
Yes, sir. Yes.
Okay, right. So it is increasing, very clearly increasing. So, yeah, now let's say I am taking another one. Let's take another one. Now I draw a curve like this. I draw a curve like this from here to here. Let's say consider from A to B. Whether it is increasing or decreasing.
But at that point, it is neither.
Whether it is increasing or decreasing. Harshika, increasing or decreasing?
Up until point C, that it's increasing. Initially, it's just a constant, and then it's decreasing, and then it's increasing, then decreasing, and then a constant.
So therefore, in the interval A to C, this is I am calling f of x. A to C, f of x is increasing, right? Similarly, in the interval C,
Yes.
f is decreasing, yes or no?
Yes, sir.
And what we say is, and in the interval A to B, we say neither increasing nor decreasing. Neither increasing nor decreasing. So can you say it is from A to B? Can you say it is increasing? You tell me. Can you say it is increasing from A to B?
No, sir.
No.
You can't say. And can you say it is decreasing? No, you can't say. So therefore, the terminology, what we use is from A to B, neither increasing nor decreasing. That's what we say. You understand? So now I am taking.
Yes, sir.
So now I am taking 3. One more curve I am taking. So let's say from A. So like this it is going like this, and then it is from here it is straight like this, parallel to x-axis. Parallel to x-axis, that is I put an arrow here, and from here it is going like this. You understand? like this. From A to B, it is increasing or decreasing?
So we can't the graph
Yes, we're not able to see anything on the board.
screen blank. Now
Now it
Are you seeing anything?
yes,
now
we
it-
can.
So from A to B, it is increasing.
yes.
From B to C, it is constant.
Yes, sir.
B to D, again, it is increasing.
Yes.
So now what we use is terminology that what we use is just a minute. Yeah. So what we use is here very important. A to B, it is strictly increasing. And C to D, it is, sorry, some net problem is there. Here. Yes, Harshika,
Yes, sir.
what happened, Rishita?
I don't know, sir. When you exited the meeting, she also left. I don't know whether it was a power cut for her also.
Okay, all right. So what I'm saying is I'm using the terminology now here. One is strictly increasing. Strictly increasing. Okay, I'm using this. Two, strictly decreasing. Okay, then next, just increasing. Increasing, this only we can call monotonically increasing. Monotonically increasing. And next, decreasing, or you can say monotonically decreasing. Monotonically decreasing. And then comes constant. Constant. Next, I told you already, this is neither increasing nor decreasing. This terminology you should understand. So here now I am giving example. Number one is this is, you see this one. Is it strictly increasing or not? You tell me. Yes or no?
So it's yes, sir. It's increasing. It's strictly increasing.
Strictly increasing, this one. Number two, I'll draw another one. This is strictly increasing or not? Yes or no? Increasing only, no? First it is minus
Yes, sir. It's strictly
minus
increasing
1,
only.
0, 1, 2, strictly increasing. Okay, wala strictly increasing, A wala strictly increasing, A wala Now you see, this is, what is this? This is, like this we have to,
Strictly decreasing.
you have to check from negative to positive, negative x-axis,
Positive.
x dash, x, so negative. So as x is increasing, this is decreasing. 4. So this, like this also it can be. See, like this also it can be. See this one, and you think about this. Just I am doing some work. Just to think about this. How is this? How is this? Can you say this is strictly increasing?
Sir,
Is a question.
no, sir, I think this is
Yeah. Yeah, this is not strictly increasing. I told you, this is just called, it is, you can call it as increasing,
yes, sir.
increasing, because of there is a break over here. We cannot say it's strictly increasing only, because from here to here it is increasing, and here is a constant, again it is increasing, but it is overall it is increasing. Yes or no?
Yes, sir.
Overall it is increasing. On the whole, you can say it is increasing, but you cannot say it is strictly increasing. Therefore, what we call is monotonically increasing.
Monotonically.
In your textbook, he did not use monotonically increasing, he did not use, just he said increasing. Okay, that is also not clear. Many of the things are not clear in the book. Okay,
Yes, sir.
so this is one thing, and not only that, sometimes graph will be like this. It is like this, and then goes like this, and then it is like this. Understand? It goes like this, it's like this.
Yes, sir.
It is constant here, again increased, constant here, again increased, constant here, again increased, like this. You understand? So you cannot say overall it is increasing, but you cannot say it is strictly increasing.
Yes. The receptionist texted, she said she'll come in 2 seconds. She's having net issues.
Similarly, decreasing wala also same like that, decreasing.
Same thing. Yes, sir.
So decreasing also, you see. You say it is decreased, but you see like this, it is constant. First it is decreased, constant, again decreased, constant, again decreased, constant, again decreased, constant, like this. You want to see? So it is here constant, 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 like that. You understand?
Yes, sir. Yes, sir. Got it.
So it is, we can use monotonically decreasing, or simply you can use decreasing. You can use decreasing. You understand? But I told,
yes, sir.
Example, y equal to x square. Y equal to x square simply. you know,
Constant.
symmetric about y-axis, you see, like this. Like this it is, you know. From, see, minus infinity to say 0, it is decreasing, है ना? From 0,
Yes, sir.
again it is increasing. So therefore, minus infinity to infinity, what you can say is neither increasing nor decreasing. You see this term, neither increasing nor decreasing. You cannot say from minus infinity to infinity, this one is a situation. You understand? This is the terminology we use.
Yes, sir.
Strictly increasing, strictly decreasing. See, always. So strictly increasing where? Where? Okay, which domain or which interval? Yes or no? Strictly increasing.
Yes.
The question. Strictly increasing where? For all real numbers. That means whole domain, whole domain or any interval. Yes or no? Strictly decreasing where? That's what is the important point. Okay, we'll ask where it is. Find out the interval. Find out the interval in which it is increasing. Find out the interval in which it is decreasing. Like that they will ask. That means what? We have to find out interval. Rishita, able to hear?
Yes, sir. I was having some net issues, so I joined with hotspot and all.
Okay, no problem. See, strictly increase. This Evala, see, first one. I am telling about strictly increasing. Like this, na? Evala strictly increasing, hai na?
Ah, yes, sir.
Second one,
Increasing only.
strictly increasing. Use this terminology.
Okay.
Oh,
Strictly
then
increasing.
next, third one.
Strictly decreasing.
Yeah, fourth one.
Strictly decreasing.
Good. Fifth one. Evala
Um,
constant
Let me
again.
see.
Simply you can say it is increasing. You cannot say strictly increasing, but overall it is increasing. Okay.
Now, okay.
Increasing, constant, increasing, constant, increasing, constant, like that. You understand?
So when it's like when there is a complete increase, you say strictly increasing. When
Yeah.
it's only like, fine.
And this is decreasing, evala constant, decreasing, evala constant, decreasing, evala constant, decreasing, evala constant, like that.
Yes, sir.
Now, y equal to x square. I gave an example. Evala, see, this one is no, from minus infinity to 0, it is decreasing. Okay. From 0 to infinity,
Yes, sir.
increasing. But minus infinity to infinity, it is called neither increasing nor decreasing. Okay, తెలుగులో చెప్తాను
Okay.
ఇంక్రీజ్ అని చెప్పలేము డిక్రీజ్ అని చెప్పలేము లైక్ దట్ ఇంక్రీజింగ్ కాదు డిక్రీజింగ్ కాదు అంతే కదా
Okay, sir.
తెలుగు వచ్చా తెలుగేనా మదర్ టంగ్
Yes, sir. Telugu only. I can't speak properly, but I can understand fully.
అడిగారు
Yes, sir.
సిటిజన్ ఆర్ వాట్
No, sir. Actually, I grew up in Delhi, so I speak Hindi better than Telugu.
ఓకే దట్స్ వాట్ ఐఎమ్ టెల్లింగ్ దట్స్ వాట్ ఐఎమ్ మీన్ టు సే ఢిల్లీ
Yes, sir.
okay good. Okay, this is what I only just explained the terminology of increasing and decreasing functions. See, I told you that's why function means it will have a curve. First thing is function. Function means what? It will have a curve. When it is a curve,
Yes, sir.
either increasing or decreasing or constant curve or neither increasing nor decreasing, whatever. It will be one of these things. It will be one of these things. Okay, this is the terminology we explained. Now, so how do we decide whether it is increasing or decreasing? Okay, what is the definition? Number one, and what is application? Applications of derivatives.
So one small doubt, sir. In the previous slide, you've written monotonically increasing. So what does
Yes,
that
yes.
mean?
Yeah. So this is what we discussed. Increasing, strictly increasing, strictly increasing and just increasing. So this only we call monotonically increasing. You understand? Monotonical increase means what? It is not strictly increasing, but it is overall it is increasing. That's only called monotonically increasing. It's not strictly increasing.
Acha.
Increasing. And similarly decreasing. It's not decreasing, but monotonically decreasing. Means what? Overall it is
sir.
decreasing only, but there is sometimes it is constant and increasing, constant and decreasing, constant decreasing. That's called monotonically decreasing. Okay, but in your textbook anyway, this monotonically increasing, monotonically decreasing, it's not there in your textbook. In your textbook, it's increasing or strictly increasing, decreasing or strictly decreasing, like that only it's there. Or constant. Okay.
Yes, sir. Okay.
Stagnate for some time, and then it is, yeah, in the interval we have, yeah, in the interval it is some interval it is constant, and I told you this is neither increasing nor decreasing. Okay, but I'm telling now, next point I'm making is, whenever we say increasing or decreasing, strictly increasing, whatever it is, 6 points, you should tell where. Where is the question? Where it is strictly increasing, then where? Where? Okay, that is which interval. In which interval it is, which interval it is decreasing. That's what is the point. Understand?
Yes, sir. Okay, so
Yes, it's where, which interval is what is important thing. Huh? That's important. Where? Question is where? Which place? Which interval? It is increasing. Okay. If I ask you that only, he will give you increasing. You have to find out the interval. Otherwise, he will give you the interval. You have to find out in that interval if it's increasing or decreasing. So now I am saying, now just I introduced the terminology. Now we are going to discuss its definition. What is actually definition? And what is the application of derivatives? By using applications of derivatives, okay, we apply derivative and find out the interval. Okay, we apply the derivative and find out, if they only give the interval, we will find out whether it is increasing or decreasing. Okay, so first of all, definition. Okay, let f is a function defined in the interval a to b. Okay, f is a function defined in the interval a to b, and you know what, and f is continuous and also differentiable. Continuous and also differentiable in a to b. Okay, function should be continuous. If there is a break, how can you say it is strictly increasing? There is no, this curve is there, here is a break, from here it is there. You cannot say it is strictly increasing because here break already is there. Understand? It should be continuous, then only you can say it is increasing. If there is no curve only from A to B, there is a gap. How can you say it is strictly increasing? There is no curve only here. So that is the reason f is continuous and differentiable. I told you differentiable means what? For example, the curve is like this. So here is a vertex. Vertex means what? It is not differentiable. I told you vertex means we can't draw the tangent. Therefore, we say it's not differentiable. Okay. So therefore, two things, because we have to apply the differentiation. We have to apply differentiation means it must be differential. So therefore, two things. One is it's continuous and differentiable in AB. F is a function defined in the interval a to b, and f is continuous and differentiable in this interval AB. Okay. Now, if for any x1 comma x2 belongs to AB such that x1 is less than x2, okay, then see what I wrote. If for any x1 x2 belongs to AB such that x1 is less than x2, then f of x1 is less than f of x2. What did you understand from this? Okay, if at all for any two numbers you take in the interval, how we are taking such that x1 is less than x2, then f of x1 is also less than f of x2. Then, okay, yeah, if okay, this is okay, you write here only. For any x1, x2 belongs to a b such that x1 is less than x2, then f of x1 is less than f of x2. Then this full stop. Then f is, what can you guess? What is the definition for this? What is the definition for this one? You take any two. I told you this, let's say A, this let's say B. From A to B, the curve is like this. x1, x2, anything you take from this. Here x1 you take x2, x1 sorry, x1 you take here, x2 you take here. x1 is less than x2, hai? Then f of x1 is, this is f of x1, this is f of x2. x1 less than x2 implies f of x1. Now that means what? As x is increasing, f of x is also increasing. Like this. x1 less than x2 less than x3 less than, like this. Then what? F of x1 is also less than f of x2. Yes or no? You understood the definition? Understand, as x is increasing, f is also increasing. As x value increasing, x is increasing. That is the definition. Definition of increasing function is as x value increasing, as x value is increasing, f of x is also increasing. Got it or not?
Got it, sir.
Got it, sir. Just writing it.
Yes. So now let's say if, so sorry, just a minute. Just I will write this. Okay. Now, for any such that x2, okay, what I will do is here only I will make all the definitions. Okay. If f of x1 is less than f of x2, then f is strictly increasing. You are clear with this? A, B. You understand? This is a condition. X1 is less than x2. If f of x1 is less than or equal to f of x2, sometimes less than, sometimes equal. You understand? From here, it is equal. See. If you take these two, what happened here? This is x1, x2, anything. x1, x2, any 2 points you take. If let's say this is x1, x2. If you take these two, you are getting less than. But if you take these two, you are getting equal. Understand? Only either less than or equal is there. Then what we say? Then f is
Monotonically increasing.
Monotonically increasing.
Is increasing. In your book it is there only increasing. So it is increasing. I think you understood now. Either less than you get or equal you get. Less than or equal you get. So it is increasing. C. If f of x1 is greater than f of x2, what happened here now? As x value is increasing, f of x value is decreasing. This only we say. Then f is strictly
Decreasing.
decreasing. Like that. If f of x1 is greater than or equal to f of x2, then f is decreasing. Okay.
Yes, sir.
If you know, if f of x1 is always equal to f of x2,
Constant.
take they are equal.
Constant.
Like this. The curve is going like this. Whatever x1, x2 you take, these two you take, or these two you take or these two you take or whatever you take, it is only equal. F of x1 also, f of x1 is increasing, x1, x2 it is increasing, but f of x1, f of, they are always same. F of x1 is always same. This means if f of x1 is f of x equal to f of x2, but we take x1 is less than x2, that means what? As x value is increasing, what is happening to f of x value? Okay, f of x value increasing, then it's increasing function, decreasing, it's decreasing function, like that. Equal, then constant. Constant. Okay.
Yes, sir.
But by this definition, you see, now you can understand. By this definition, if any one of this relation is, if f of x1 is, you can't say any nothing like this. See, less than you can't say, less than or equal you can't say, greater than you can say, greater than or equal you can't say. That means what? You understand? Sometimes it is less, greater than. Sometimes it is equal. This is also there. All the relations are there, you see. Some f of x1 is less than. That means what? All three are there. What is the use of this? You see. All are there. All are coming. Means what? Neither increasing nor
Neither increasing nor decreasing. Yes, sir.
is there. No, everything is there. So, like that. So this is a definition. That means what? This is simply as x value is increasing, f of x value is increasing. See, f of x value is strictly increasing, f of x value is increasing, f of x value is decreasing. See, decreasing or strictly decreasing. Yes, sorry, here strictly decreasing or it is decreasing. This is the definition. Here it's constant. Here nothing, neither increasing, neither less, greater, everything is there. That is what here increase, like here see decrease, here constant, here increase, like that means what? Neither increasing, not decreasing. We see. Okay, you are clear?
Yes, sir.
Now application you see. Or theorem. Same. Let f is continuous. Always we say continuous on closed interval AB and differentiable on open interval we say AB. Always this we say. Continuous is in this interval it's continuous, and differentiable on open interval we say, because at the end points it is, see, one curve is there. At end point you cannot draw the tangent. Already I told, end points you can't draw the tangent. At end points you can't draw the tangent. Therefore we remove these end points. So if is defined in the interval a to b, a b lo defined అయినప్పుడు what we say in the open, it is differentiable in the open interval AB we say, because at the end points you can't draw the tangent. Therefore, we don't take end points when we say differentiable. So here, therefore, it is continuous on closed interval AB and differentiable on open interval AB. Okay. Here also. Here also, number one. Here, f dash of x is greater than 0, strictly greater than 0, for all x belongs to AB. Okay, whatever you take, it is slope of the tangent. F dash of x is nothing but slope of the tangent. Slope of the tangent is always positive. Then we say, then f is strictly decreasing. Sorry, strictly decreasing. F dash of x is slope is greater than or equal to 0 for all x belongs to AB. Then we say f is increasing in the interval AB. Okay.
Yes, sir.
Yes, sir.
So I will tell you why. Because you see, already I showed you through the graph, I already showed you, right? Show like this. So Evala, you see, x1, Evala, x2, Evala, x3, whatever you take, x3. You draw the tangent, slope of the tangent, you see positive or not. Tan theta, positive or not, greater than yes or no?
Yes, sir, it's greater than 0.
Greater than 0 because theta is angle is, theta belongs to 0 to 90, see.
So it's not, it's minus pi by 2. Yes, sir.
Slope of the tangent. Tan theta formula.
Yes, sir.
Okay, here also you draw. Here also you draw. It is decreasing. As it is increasing faster, as it is increasing faster, you see. So like that, even if it is going like this, also it is like this. Yes or no? But less than 90 degrees, you see. But for decreasing, what will happen? For decreasing, let's say it is decreasing. What will happen? You draw the tangent here. What will happen? Draw the tangent anywhere. Draw the tangent anywhere. What will happen? What is happening here? Yes or no? What is the angle?